learned how to do that. All right. So the first thing that we wrote at the top was going to be matter. What is matter, right? So matter, what you guys wrote down, if you were someone who wrote it down, was anything that has mass and takes up space. Anything that has mass and takes up space. So people who wrote it down yesterday, what did we put after the word takes up space? Volume, exactly. So anything that has mass and volume is the definition of matter. Okay, so that's pretty much everything. All right, within matter, atoms are constantly in motion. Okay, no matter what. Even solids, those particles are sitting there wiggling. Okay, they're vibrating. Okay, so no matter what, everything is in motion, and the movement of that is going to depend on what the state of matter is, or the current phase. Okay? All right, so moving on, we have our different states of matter. So what I want to kind of point out was that we have these little pictures. So if you wrote down stuff yesterday, you probably wrote down along the side what these three things are called. Did anybody write what that was? Started with a P. Or was that not on there? Yeah, there you go. Particulate diagram. So go ahead and write that long word. Particulate. Okay? So particulate diagrams. And that is all these little bubbly pictures. All right? So the little circles that are there. And all that a particulate diagram is a zoomed in version of whatever you're looking at macroscopically, right? So it's once again building a model so that you can conceptually figure out what's actually going on, okay? So it's a model. So particulate diagrams, I just want you to be familiar with what that is because I ask you guys for sure to analyze them and draw them, okay? All right, you can turn your paper back. Okay, so when we're talking about gases, we're going to say that the size or volume is indefinite, which is a weird word, but it just means it's not definite. It means that it can change. That's all that I'm trying to get you to think. So it can change. It can get bigger and smaller. Shape will change by the container. So that also means indefinite shape. Okay, so an indefinite shape, indefinite volume. We're going to need that for the Venn diagram. There's lots of free space between the particles. Okay, there's lots of free space between the particles, which makes it compressible. Compressible is only for gases. And what it means, because everybody, when you hear the word compression, you're like, oh, well, Hulk smash, like he compressed the car. Different, totally different, okay? Compressible in this manner is talking about taking those particles and pushing them close together to change your state of matter. All right, so it's not Hulk smashing, because if you think Hulk smashing, then you're like solid, liquid, and gas. They all compress. No, gases are the only ones that are compressible, right? Think about little containers of aerosol cans, right? Oxygen tanks, things like that. We compress the air to fit it into a smaller container. Those are the only ones that can do that, gas, okay? All right. Particles are able to flow past one another. So the fancy word that we're going to use to define that is the word fluid. Okay, fluid. Okay, so everyone usually misses that for gases. Gases are considered fluid because of this property that they can flow past one another. Okay. All right, so somebody who was copying down yesterday, tell us what is the boiling point of water? Good. Oh, yeah. Oh, I had it both there? That's cool. All right, so 100 degrees Celsius, that's all you really have to write, but if you want it, 212 degrees Fahrenheit. Okay. But we are in science class, so 100 degrees Celsius is all you really need to know. Okay. All right, so that's the boiling point and condensation point of water. So while we are on this note, since I'm just going to give you guys the same little spiel that I gave to the morning classes who had already wrote this stuff in, I'm going to put this up on your screen. Make sure we're writing our notes. Okay. There you go. This. All right. So what this shows is we have a graph that is basically running you through different changes in states of matter, right? So we're going to fill in those arrows on your page in just a few minutes, okay? But what I wanted to point out was when you see a graph like this, minus the big mistake right here, this should be at the letter D, and this should be the letter E according to this. All the diagonal parts are your different states of matter. So solid, then liquid, and gas. These parts that are flat are kind of showing two different things, and you see that with the key over here. So solid and liquid, liquid and gas. That means that is the melting freezing point, and this is your boiling point, condensation point, okay? So I wanted to show you this graph because you're probably going to see it tomorrow with a little writing prompt, all right? And I just wanted to kind of make sure that you've seen it before. What it has to do with is changing your states of matter. But you have two things going on at the same time. And you can kind of look around and see that heat is being added. So basically you start right here at 100 degrees Celsius. And then if I add a little bit more heat, I'm now in the gas phase. If I take away heat, I'm in the liquid phase. That's the way it works, okay? All right, so back to my, I was going to say hovercraft, but it's not. It's hovercam, but it's like hovercraft. Okay, sorry. Anywho, so we got our boiling point of water. So we can fill in the two changes of state. So what is it when the liquid is turning into a gas? Evaporation. Good. Okay, evaporation could also be vaporization. You'll hear it be called that as well. And then a gas down to a liquid is going to what? Condensation. Yep. So when you have a cold bottle of water out in the hot sun, it's going to form droplets on the outside or inside my classroom, obviously. And it's going to form droplets, right? And that is the air around it is condensing down to a liquid. So gross fact, a lot of you guys like to use that to like wash your hands, right? You just washed your hands with everybody's breath. Yeah. So when you wipe your bottle, like wipe your hands on your bottle to get your hands wet to kind of wash them or whatever, it's technically everybody's air and breath that just condensed into liquid form. Yeah. Grody. All right. So anyway, back to this. I just had my public service announcement. All right, so we got gas done. Liquid. So liquid, we have keeps its size, meaning keeps its volume. So that means it's definite. That's the word that you're going to be seeing used, especially when we get to the Venn diagram, okay? The shape, however, changes by the container. So that means it's indefinite. So indefinite shape, but definite volume. This definite volume is how you have like a small beaker of water and you pour it into a large container. It's still that small beaker of water's worth, right? The volume didn't change, but the shape did. Okay. Particles can still flow past one another, which means we are dealing with the word fluid again. Okay, so there's our other fluid. So there's two fluids, gas, liquid. All right, so moving on to the next part, we've got the melting or freezing point of water. What is that? 0 degrees Celsius, which is 32 degrees Fahrenheit. Okay, so at 0 degrees Celsius, okay, we are having that melting and freezing point. So once again, that was what I meant by the graph, right? Was this little part right here. Right here, we're at 0 degrees Celsius. And then if we move a little bit more this way, now I'm going to, if I lose some energy, now I'm going to be frozen. I'm going to be solid. If I gain a little bit, I'm going to go liquid. Okay? So just wanted to make sure that you guys are able to interpret that. I lost my mouse in the meantime. Hold on. There it is. All right. We're good. All right. So let's talk about what these changes are. A solid down to a liquid. Melting, good. Now, if you wrote it yesterday, what did you see the other word? What did I put? Fusion. All right, so this is one that I want you guys to know for sure because it always bothers people. There's been some teachers that I've had to correct before on this one because when you hear the word fusion, you're like, that's more like freezing, right? Like in our heads, that's what fusing something together means, making it stick. So fusion, if you go look it up with chemistry and things like that, it's actually breaking it apart. So if you have a heat of fusion, you're talking about what is the energy required to break something apart. It's kind of weird. So I just wanted to make sure that you guys got to see it at least on these notes. So, but we will be using mostly the word melting, all right? Don't have to worry about that popping up if it's going over your head. The other side, we have liquid down to a solid. What is that called? That is freezing. I know. Oh my gosh. What? Yeah, I have nothing else to say about that. All right. So our last state of matter is going to be a solid. So that kind of got cut off on your page. So hopefully you can just fill that back in. So solids are going to be the only one that keeps their size and their shape, which means that it's fixed or definite volume and shape. Definite volume and shape. Solids are not a fluid. They don't allow their particles to flow past each other, but it is important to remember they are still moving. It's more like vibration. Okay? And when we get to electron configuration, things like that, you can kind of start seeing that. So that's all that we have to write right here. So I just wanted to point out on the side, we have two other states of matter changes, and that is the sublimation. That's when you have a solid going straight to a gas. So if you've ever seen dry ice, especially during Halloween time, that is sublimation. It's going straight to being a gas. If you have gas freezing directly into a solid, that is deposition. The easiest place to find that is in your freezer. You can scrape the sides, and usually there's like a light, fluffy little frost in there, and that's usually the air inside freezing to solidify, okay? It is not the same thing as when you have, like when your freezer it was dripping with water and then it froze. That's different. So it's a really light, fluffy stuff that forms on the side. Okay, any questions?